I'm tackling a problem where my kernel-ridge model, which uses a kernel method for nonlinear regression in Sklearn, is overfitting. That means it's performing great on my training data but poorly on new data. I need to find ways to improve its generalization ability. Let's fix this. My Sklearn kernel-ridge model is overfitting. The model learns the training data too well, including noise. This results in poor performance on unseen data, indicating a need to decrease this model's complexity. This is a classic machine learning challenge. I'm looking for strategies to reduce overfitting. Overfitting happens when a model is too complex for the given data. It learns both patterns and noise in the training dataset. We need to consider ways to simplify this model. I can increase the alpha hyperparameter. Alpha controls the strength of L2 regularization, which adds a penalty for large model coefficients. A higher alpha shrinks coefficients, making the model simpler and reducing overfitting. Think of it as adding a brake to prevent the model from going too wild. I can decrease alpha. Decreasing alpha reduces the regularization strength, which is the opposite of what I need to fix overfitting. The model becomes more complex and more likely to overfit. This is unlikely to help. I could switch to a more complex kernel. A more complex kernel, like the RBF kernel, increases the model's capacity to fit the data, making it more flexible, but also much more likely to overfit, especially if my data isn't complex enough to justify it. This usually makes overfitting worse. I could use a simpler kernel. Switching to a simpler kernel, such as the linear kernel, reduces the model's complexity. This lowers its ability to overfit, improving generalization to unseen data. This often helps reduce overfitting. I see that the core problem is overfitting in a kernel-ridge regression model. Overfitting means your model is learning the training data too well, including the noise, and it's not generalizing well to new, unseen data. We need strategies to improve the model's ability to predict accurately on new data. We are specifically using Sklearn's kernel-ridge, a powerful tool for nonlinear regression. The challenge is that it's currently overfitting, which means it's performing really well on the training data but poorly on new data. We need to solve that. I'm going to explore several strategies to tackle this overfitting problem. Let's see what we can do. Increasing the alpha hyperparameter increases regularization. Regularization helps to constrain the model's complexity, preventing it from fitting to noise in the training data. Think of it as adding a penalty for overly complex models. This directly addresses overfitting. Decreasing alpha reduces regularization, giving the model more freedom. This increases the risk of overfitting, because the model can fit noise better, so it is not a good choice to solve our problem. Using a more complex kernel function, like an RBF kernel, radial basis function kernel, instead of a linear kernel, increases the model's capacity to fit complex relationships. This can lead to overfitting if the underlying relationship isn't that complex in the data. Switching to a simpler kernel, like a linear kernel instead of an RBF kernel, reduces the model's complexity, limiting its ability to overfit to noise. This is a good strategy for dealing with overfitting, because it will reduce models' capacity to be overly complex. I see alpha as a tuning knob that controls how much I trust my data. A larger alpha means I'm more cautious, shrinking my model's coefficients towards zero to avoid overfitting. Think of it as adding a penalty for complex models. A smaller alpha means I'm more trusting, allowing my model greater flexibility, which can lead to overfitting if I'm not careful. It's a balance. The kernel is how I measure the similarity between data points in high dimensions, which I can't directly see. A simpler kernel, like a linear one, creates a linear decision boundary. A more complex kernel, like an RBF, allows for more flexibility, creating a curvy boundary. More flexibility means a higher risk of overfitting because I may try too hard to match noisy training data. It's like trying to fit a very complicated curve through scattered points. The fit may be perfect for the points, but terrible at predicting new ones. Overfitting in kernel-ridge regression is a scenario where my model memorizes the training data too well, including noise, making it perform poorly on unseen data. It's like a student who memorizes the answers to the practice test but can't answer the real questions. I'm trying to reduce my model's complexity and prevent it from learning the noise in the training data. This ensures it generalizes better to new data. We'll explore strategies to make it more robust to unseen data. I'll explain how the alpha parameter in kernel ridge affects the model. Alpha controls the strength of L2 regularization. A larger alpha value increases regularization, forcing the model's coefficients towards zero. This simplifies the model, reducing its tendency to overfit. A smaller alpha value reduces regularization, allowing the model more freedom and increasing the risk of overfitting. Think of it like this. A large alpha is like adding friction to a complex machine, making it run simpler and smoother, while a small alpha is like removing friction, allowing the machine to move more freely, but also making it prone to shaking and instability. I'll explain kernel functions and their effect on overfitting. The kernel function determines how the model measures similarity between data points. Complex kernels, like the radial basis function, RBF, kernel, are flexible and can capture highly nonlinear relationships. But this added flexibility means they are more likely to overfit. They can memorize the training data rather than learn the true underlying pattern. Simpler kernels, like linear kernels, have less flexibility, reducing the chance of overfitting. So, choosing a simple kernel is like using a simple tool for a simple job, efficient and less error-prone. Using a complex kernel for a simple job is like using a jackhammer to crack a walnut. It works, but it is excessive and carries a risk of damage. This question is asking you to identify methods to prevent overfitting in a kernel ridge model. Overfitting happens when your model learns the training data too well, including its noise, resulting in poor performance on new, unseen data. We need to find techniques that reduce this overfitting behavior. This is the core problem. We're using kernel ridge regression, a powerful method for modeling nonlinear relationships, and we are seeing issues with overfitting. The goal is to find ways to improve the model's ability to generalize to new data, making it less sensitive to the quirks of our existing training data. I'm tackling the challenge of overfitting in a kernel ridge regression model. This happens when the model learns the training data too well, including its noise, and therefore performs poorly on new, unseen data. We want a model that generalizes well to new data, not one that just memorizes the training set. Let's see how to fix this. I'm using scikit-learn's kernel ridge to model a nonlinear relationship. My current model is overfitting, and I need strategies to improve its performance on new data. I can increase alpha. Alpha controls regularization strength in kernel ridge, which helps to prevent overfitting by penalizing overly complex models. A higher alpha means stronger regularization, making my model simpler and less prone to overfitting. Decreasing alpha is a bad idea because it weakens regularization. This would allow the model to become too complex, potentially leading to even worse overfitting. Switching to a more complex kernel like RBF increases the model's capacity. This is risky as it could allow the model to overfit even more, unless the data actually justifies such complexity. I can try a simpler kernel. Simpler kernels, like linear ones, reduce the model's flexibility and therefore, its capacity to overfit. This is a good approach to control overfitting. We're tackling the challenge of overfitting in kernelridge regression, a technique that uses kernel methods to model nonlinear relationships. Overfitting happens when a model learns the training data too well, including its noise, and doesn't generalize well to new, unseen data. I'll show you how to deal with it. I'm using sklearn to predict a value based on some features. But the model fits the training data too closely, which means it performs poorly when given new, unseen data. This is a classic case of overfitting. I need strategies to fix it. To combat overfitting, I need to choose the right methods. I'll examine some options involving hyperparameter tuning and kernel selection to improve the model's generalization ability. This option involves increasing the regularization strength. The alpha hyperparameter in kernelridge controls the amount of L2 regularization, ridge regression. A higher alpha means more regularization, which shrinks the model's coefficients toward zero, reducing complexity and thereby preventing overfitting. Think of it like this. I'm adding a penalty for model complexity. Reducing alpha means less regularization. This gives the model more flexibility, but too much flexibility can lead to overfitting. It's like giving a child too much freedom. They might become unruly. A complex kernel, such as a radial basis function, RBF, kernel, is more powerful and can capture intricate relationships in the data. However, this increased power can lead to overfitting if the data doesn't justify that complexity. It's like using a sledgehammer to crack a nut. A simpler kernel, such as a linear kernel, limits the model's ability to fit complex relationships, thus reducing the risk of overfitting. This is a good strategy when the relationship between features and the target is relatively straightforward. We're tackling how to prevent overfitting in a kernel ridge model, a type of regression that uses kernels to handle nonlinear data. Overfitting happens when your model learns the training data too well, including its noise, and performs poorly on new, unseen data. Think of it like a student memorizing the answers to a test without understanding the concepts. They'll ace that specific test but fail any other. We'll explore strategies to avoid this. Let's dive in. You're using kernelridge from Sklearn, a powerful tool for regression. But you've run into a common problem: overfitting. Your model is too closely tied to your training data, and you need ways to improve its ability to generalize to new data. I'll help you find the best solutions. This question focuses on practical solutions. I will guide you through the choices presented to help you identify those that specifically address the problem of overfitting in a kernel ridge model. Let's explore the options step by step. Increasing alpha means increasing the strength of regularization. Regularization adds a penalty to complex models, pushing the model's parameters toward zero. This simplifies the model, making it less prone to overfitting. It's like adding a complexity tax to make sure the model doesn't get too fancy. This is a good one. Decreasing alpha weakens the regularization. This gives the model more freedom to fit the training data, potentially increasing overfitting. It's the opposite of what we want to achieve. We're looking for ways to constrain the model's complexity. Using a more complex kernel increases the model's ability to capture intricate relationships in the data. However, this increased flexibility makes overfitting more likely, especially if the data isn't truly complex. A simpler kernel may be better suited if the relationship between data and output is less complex. Switching to a simpler kernel limits the model's ability to capture intricate relationships. This reduced complexity helps prevent overfitting by making the model less sensitive to noise in the training data. It's a great way to control the model's capacity.